A rotary compressor uses a rolling piston within a cylindrical housing to compress vapor against a reciprocating vane. The spring above the vane holds it in contact with the rolling piston at all times, providing a vapor-tight seal between the high and low pressure zones within the compressor. The rotary compressor requires only one valve, the discharge valve. Compression and suction occur simultaneously on opposite sides of the rolling piston, so it takes 2 full revolutions of the shaft to draw in and compress a volume of vapor. Let's start with the rolling piston at top dead center. As the eccentric shaft rotates the rolling piston from top dead center past the suction port begins to open and a space begins to form between the vane, the rolling piston, and the housing. With continued rotation, the volume of this space increases, reducing the pressure below the low side pressure in the cycle. Vapor is then drawn in through the suction port. This continues for a full revolution until the compression volume is filled with suction vapor at low pressure. During the next rotation, the suction port is blocked by the rolling piston. The low-pressure vapor is then compressed in the space between the rolling piston, housing, vane, and discharge valve on the other side of the piston. Initially, the discharge valve is closed, trapping the low-pressure vapor for compression. Continued rotation of the rolling piston along the inside of the housing reduces the volume of the vapor, compresses it against the vane, and raises its pressure. When the vapor pressure exceeds the high side pressure, it pushes open the discharge valve. Discharge continues until the rolling piston completes the full revolution and has expelled most of the high-pressure vapor. The discharge valve closes when the rolling piston reaches top dead center.